Hey, Brett.
Where am I looking? Oh, with that thing.
That's them there, yeah. It's a little disconcerting. I keep
How
looking
come
down
you
here.
can't see them? This is
Um,
Oh, you can.
Well, you can see them. Megan's drinking.
yeah.
I usually come home, see how those more often. I get tea.
Brett's out of here. Okay. So the derivative of e to the x is equal to limit as h goes to 0 of e to the x plus h minus e to the x over h. And we can actually factor out an e to the x. And so this is just using our sort of exponent rules. When we multiply two powers with the same base, we can just add the exponents. So when we factor e to the x out, we're left with e to the h, and we're left with a 1 when we factor e to the x out of that. So nothing new has happened. So this is the limit as h goes to 0. Okay, so e to the exponent h is the same thing as e to the exponent 0 plus h. And minus 1 is actually the same as e to the exponent 0. And that's over h. And so based on the definition, who can tell me what that's equal to?
1.
Exactly. Yeah. And so actually when we put in our limit, we're just left with e to the exponent x. So the derivative of e to the exponent x is equal to e to the exponent x. So that's a development of that formula. Normally it's done with the limit of that expression, 1 plus 1 over x to the exponent x. This is kind of a simplified version. Anyway, it's really quick and easy to do, so I like it. So I'll probably get you to reproduce this proof on maybe not the next test, but the test after that. Everybody's good?
Yep.
Thumbs up. Perfect. Okay. Now we can we'll just do some derivatives. Because they're easy. Who wants to give it a shot?
Um,
3x times e to the power of x squared.
Oh, it's not bad.
3x squared.
Megan?
Cube?
Cube.
Cube?
There you go. Yeah.
Oh, I just forgot to square that. Sweet.
Yep. So we're just doing the chain rule. So it's the derivative of e to the exponent this, which is just e to the exponent this. And then we do the derivative of the inside function, which is x cubed.
Oh, okay.
So that's the trickiest thing, is just recognizing these as kind of chain rule functions. Who remembers what the derivative of sine is?
Coach?
The derivative of sine x is cos x. Yeah. All right. Meg, you should go first this time.
Cos x times e to the exponent sin x.
Beautiful. Perfect. Let's step this up a notch. There we go. I think I've got eye contact. What did you get, Luke? Oh, what rule did you use? Or what two rules? Yes.
Is it like a super long answer?
Yeah, like it's kind of a mess, and we'll actually have to kind of factor it a little bit afterwards.
Alright.
I did do it then.
Yeah.
Is it negative 6x times e to the power of negative 3x squared times e to the power of negative 3x squared
Oh.
again?
Uh,
Or, yeah.
okay. So you've done the derivative of,
I just drew the second one.
yeah,
And then, so it'll be x5, x to the power of 5.
exactly. Yeah.
And then plus 5x to the power of 4 times e to the power of negative 3x squared.
Correct. Yeah. Very good. And Meg, is that roughly what you got?
I forgot to do power rule, but yeah.
Oh, okay, all right. Okay. I've just simplified it a little bit. And usually in calculus we like to factor as much as possible. We like to factor our derivatives. Mostly so when we do our curve sketching, we can find out some of the important things like the maxima and minima, and intervals of concavity and the sign. So what is a common factor in both of these terms?
E to the exponent negative 3x squared.
Yep, there's definitely an e to the exponent negative 3x squared in both of them. And
X to the power 4.
x to the power of 4 can also come out of everything that's in there, yeah. Okay, so we're left with a 6x squared, sorry, a negative 6x squared, and plus 5. Oh, okay, I went really crazy with my bracket. There we are. So there it is, factor, and that's something that you sometimes have to get used to, just because when we have the factors, we can find the zeros a lot easier. Oh my goodness! Come on in.
Who's visiting now?
Well, this is the dinosaur hunter. So, Luke, you remember Chompy and Chompy and those dinosaurs?
Yeah, the critical angle.
Yeah, that's right. Here comes our filmmaker now.
Oh, hey Isaac.
So, who is myself?
Hey Isaac.
This is Isaac. He's
Hi,
been
Isaac.
he was part creator of those YouTube videos with the dinosaurs.
Special.
Yeah, that's right. So, and he was at University of Ottawa studying dinosaurs.
Carlton.
Carlton.
Paleontology, yeah.
Okay.
You got it.
Okay. Isaac, what's the derivative of y equals e to the exponent x?
Oh god, e to the x.
Yes.
Calculus was
man.
last term, right?
Is that right?
Yeah.
That's, this is Luke. Luke Churchman.
Ooh, nice to meet
How's
This
it
is
going?
Megan.
Oh, that's Megan there.
you. Alright, I think I know that.
Yeah. RJ didn't come.
Archie didn't come.
Yeah.
He's no fun.
And
Are
sometimes actually didn't show up. Shows
Just
up too.
started Euler's number.
Yes, we did. Do you guys call him Euler?
We just, I think everyone just called it, like no one ever gave it like the proper name.
No, is that
Everybody
right?
said it was E.
Yeah.
It was just E. It was
So I've-
no fancy.
I've heard it pronounced Euler, and I've heard it pronounced Euler.
Yeah.
Yeah.
I see Euler. If it was Euler, then it'd be an O.
Every time I looked at it. Anyway, every time I looked at it, I always said Euler. Anyway, it turned out a lot of people say Euler, and then I've heard other people call it like something totally different. What about that name Churchman? Is that German?
No, it's Ukraine.
Is it really? Wow.
Yeah.
Do you are you like close to anybody in the Ukraine, or is that
No, it's
you're a few generations?
yeah, because like my grandparents are like Irish and English, so
Oh, okay.
yeah.
All right. Okay, let's try this one.
I just got off one of your algebra.
Oh, how'd that go?
It went pretty good. It was so ridiculous though. It's like they wanted everyone to pass.
Oh,
They
okay.
were allowed to cheat sheet.
Ooh, studying your algebra.
Yeah, I know. I thought, why? I really put that for calculus because there's so many like, there's like no derivative rules for certain ones. You just have to memorize over and over again. Arctan, Narcos, and so
Oh,
things like
those
that.
are brutal, yeah.
Like, you have to memorize. I was like, I had to memorize this. I don't remember them now. But no, we had a cheat sheet, and there was a policy for questions 4 through 6 on the exam, and the long answer ones. And if you don't answer any of them, you get 20% of the marks already.
Oh.
And you get guaranteed 20. I could leave like the whole, probably get 20% of those.
So if you're gonna do it totally wrong, you'd be better off not doing it.
No, like the marks just add on if you just try it. It was just so. I just thought it was just really silly. It was just a silly.
That's silly.
It was very silly. There's the calculus class. Then.
Yeah.
Just where so RJ's down here.
Yeah, RJ's visiting his cousin.
I put air quotes.
Yeah.
Yeah.
Yeah. We think it's his girlfriend, yeah.
Yeah, probably girlfriend.
Yeah. We don't know where Reed is. He's
He's
Yes,
off.
Lithuania.
He's off the map.
but he comes kind of regular to calculus too. So
Oh, okay.
yeah.
What has Reed been up to, anyways? Talk to me more.
Just doing the exchange.
Yeah. So what's he planning to do when he gets back?
Oh, well, he's back down at doing Bayside Astronomy.
Okay. Right.
Okay. I think I've got double eye contact. Anybody, what rule did you use? Yep.
Product.
Said
Send with fear.
with fear. Yeah, you can use the product rule. You could also simplify it first if you'd wanted to. But product rule's good. Who wants? Hey, Meg. I think Luke did the last one.
Okay. I have e to the x times e to the 4x.
E to 4x. Oh, so you did the derivative of the first times the second. Yeah.
Yeah, then I'd be backwards. I'm sorry.
No.
Plus, I'm not sure what 4e to 4x. Times e to the x.
Yep.
That's right.
Perfect.
Sweet.
And good. Oh, man. Can we do some factoring here? Probably. Oh. Oh yeah, take this. So altogether we've got e to the x, e to the 4x, and we've got 4 of them over here. So we can have 5 e to the x, e to the 4x. And when we multiply powers with the same base, what do we do to the exponents?
Add.
Add them. So we can actually simplify that to 5e to 5x.
Beautiful.
Or we could have even done this. What's that, Luke?
Don't you have to multiply them first, though? And then,
Oh, you mean,
alright,
yeah. So it's the same base. So when we multiply them together, we actually just end up with exactly the same base. And then we add the two exponents together.
Right.
But we could have done that here.
Aha.
So we could have went that way too.
That's too easy.
Yeah.
That's easy.
That was the.
What is the velocity of an unladen swallow?
What's your favorite color?
Yellow.
What? Give me out name.
Sorry, Luke.
We wish for you to bring us a shrubbery.
There's
Let's just send it out
Yeah.
to Monty Python.
yeah, it's Monty Python. I don't know.
Always like a lion's head thing.
Yeah, we've already identified ourselves.
And wish. Just start calling it a Monty Python line, see who responds.
There we go. So, Luke, sorry, I don't have the, I'll put the exercises on the course website right away. But if you want to try the interactive quiz, that gets you just your basic bread and butter derivatives. And then in the exercises, I think we can just sort of skip. I expect we don't have to do 1 and 2. I think they're pretty easy. But let's do, we'll do 3A and B. Yeah, and let's do 4C and D. Five, 9, and I'd like you to try that one, which is number 10. Mostly because number 10 is kind of it's interesting from a physics standpoint because it basically it's one of the differential equations we use for forced oscillating systems. It's kind of neat. So give it a shot, and we'll look at it on Monday. All right. Is that easy?
Are we supposed to be able to see you right now?
Oh, right. Luke, you're supposed to tell me when I'm.
Look! Good one job!
She has my back, I guess.
Yeah.
Screwed up.
Yeah, I'll be writing stuff on the board. Luke's really polite. He says, "Well, I can't really see what you're writing right now."
I can see what you're
Yeah. Yeah, that's funny. It looked fine to me.
Yeah, that's fine. Go right.
That's good. Okay, so you able to join us on Monday, Luke?
Yeah.
Perfect. So see you guys later. Bye.
Bye.
Yeah. Have a good weekend.
You too.
It's a cool setup you have.